So welcome students. So let us look at this question. So in this question you are given two statements. X square by 25 plus y square by 16 is equal to 1. Ellipse 12x square minus 4y square is equal to 27. Hyperbola intersect each other orthogonally. This is the first statement. The second statement is two confocal ellipse and hyperbola, if intersects, they always intersect orthogonally. So are these two statements related to each other? So first let us see whether there is a relation between these two statements. So the second statement says if the ellipse and hyperbola have the same focus, same foci, they will intersect orthogonally. And you have two equations, an ellipse and a hyperbola in the statement 1. So let us first check whether these two are confocal or not. So if these two are confocal, then if S2 is right, S1 will automatically be right. So what is the eccentricity of the ellipse? Eccentricity is root of 1 minus b square by a square, that is equal to 3 by 5. So this implies AE is equal to 5 into 3 by 5, which is equal to 3. Hence the foci are plus or minus 3 comma 0. It's a horizontal ellipse, so plus or minus 3 comma 0 are the foci. So if you take the second equation, which is a hyperbola, so the equation is something like this: x square by, so if you divide by 27, so 27 by 12 minus y square by 27 by 4 is equal to 1. So what is the eccentricity of this? Root of 1 plus b square by a square, 27 by 4 by 27 by 12, that is equal to root of 1 plus 27 and 27 gets cancelled, 12 goes up, 12 by 4 is 3, that is equal to 2. The eccentricity is 2. Now what is AE? AE is nothing but A is root of 27 by 12, that is if you cancel 3 out, so 27 by 12 is nothing but, so 9 by 4. So root of 9 by 4 is 3 by 2, this is a square, so A is 3 by 2 into 2, that is equal to 3. Hence the foci of hyperbola are also plus or minus 3 comma 0. So these two, this ellipse and this hyperbola, have same focus, same foci. Now the first statement says that these two are orthogonal. The second statement is two confocal ellipse and hyperbola intersect orthogonally. So let us check if this statement is right. So if you want to check the second statement, let us say that you have an ellipse and a hyperbola. So x square by a square plus y square by b square is equal to 1. This is an ellipse, and x square by a square minus y square by capital B square is equal to 1 is the hyperbola. So let us assume that these two are confocal. That means the focus of this should be same as the focus of this. So AE of the first should be same as AE of the second. So what is the focus? What is the coordinates of focus of this? A into root of 1 minus b square by a square. That implies that is equal to, so what is the focus of this? Capital A into root of 1 plus b square by a square. That means root of a square minus b square is same as root of a square plus b square. So if you square it on both sides, so a square minus b square is equal to capital A square plus capital B square. So this is the condition which ensures that both this ellipse and this hyperbola are confocal. Now if these two are confocal, that means if this condition is valid, so let us check whether these two are intersecting orthogonally or not. Now, so let us say that we have some point of intersection between these two. So if you take a parametric point on this, so now let us check that if this ellipse and this hyperbola are confocal, are they orthogonal to each other? Can we prove that with this condition they are orthogonal to each other? So now to prove that, let us assume that the point of intersection of these two is x1 comma y1. So let us assume that x1 y1 is the point of intersection. Now what is the value of the slope of tangent at the point x1 y1 with respect to this ellipse. So if you differentiate this, you get 2x by a square plus 2y dy by dx by b square is equal to 0. So this 2 gets cancelled. So dy by dx is equal to minus x1 by a square into b square by y1. This is the value of dy by dx at x1 y1. So you just need to send everything on to the other side. So this is the slope of the tangent to the ellipse at the point of intersection. So if you take the same thing with respect to the hyperbola, so 2x by capital A square minus 2y dy by dx by capital B square is equal to 0. So what is dy by dx with respect to the hyperbola at x1 y1? It is minus of x1 by a square into b square by minus y1. So these two are getting cancelled. So one slope is minus b square by a square times minus x1 by y1. The other slope is minus b plus b square by a square into x1 by y1. So now let us check whether these two are orthogonal to each other. That is, let us check whether these two slopes have a product of minus 1. So now once you got these two slopes, so let us check whether the product of these two slopes is equal to minus 1. If the product of these two slopes is equal to minus 1, then I can say that these two are orthogonal, otherwise not. So what is the product of the slopes? m1, m2 is nothing but minus of b square into capital B square by a square into capital A square into x1 square by y1 square. So I just need to find the value of x1 square by y1 square. So we know that x1 y1 is the point of intersection of the ellipse and the hyperbola. That means x1 y1 satisfies the ellipse and the hyperbola. Now if I can solve these equations for x1 square and y1 square, I can find the ratio of x1 square and y1 square. So let me use the cross multiplication method. X1 square, y1 square, 1. The coefficients are 1 by a square, 1 by b square, minus 1. And 1 by capital A square, 1 by, so minus 1 by capital B square, minus 1. So by cross multiplication rule, you get x1 square divided by this into this minus this into this, minus 1 by b square minus 1 by capital B square, minus 1 by small b square minus 1 by capital B square is equal to minus y1 square by minus of y1 square by this into this minus this into this, that is minus 1 by a square plus 1 by capital A square. So is equal to, you have 1 by something, doesn't really matter. So I am only interested in the ratio of x1 square by y1 square. So I will use this. So this implies x1 square divided by minus comes common. So capital B square plus small b square, and capital B square small b square goes up. Capital B square small b square is equal to, so in terms of y1 square, so you have minus y1 square divided by, so if you take LCM, you get small a square minus capital A square, small a square minus capital A square, and the denominator, which is LCM, goes up, that is a square capital A square. So this implies, so as you can see, minus of x1 square into b square capital B square. So I'll send this into the denominator, divided by I'll leave the minus here. So y1 square into small a square capital A square is equal to minus of b square plus capital B square by a square minus capital A square. And as you can see, this is nothing but the term m1 m2. So m1 m2 is equal to this, but because these two curves are confocal, we have a condition which is like this. So from this condition, can you see that if you rearrange terms, are you getting a square minus capital A square is equal to b square plus capital B square? So if you interchange, a square minus capital A square is equal to capital B square plus small b square. So can you see that these two are getting cancelled, which is equal to minus 1. So if the curves are confocal, that is ellipse and hyperbola are confocal. So these two are getting cancelled and m1 into mt is turning out to be minus 1, which ensures that the curves are orthogonal. Hence, statement 2 is true. That is, if the ellipse and hyperbola are confocal, they intersect orthogonally. Hence, statement 1 is also true because these two are confocal, and statement 2 is the correct explanation for statement 1. So that will be the answer to this question. Thank you.